We typically think of dreams as an abstract psychological theater, your brain playing out unresolved emotions or quietly filing away memories while you sit in standby mode for the night. But the brain is not a passive hard drive, it is a fiercely competitive ecosystem. Because of a feature called neuroplasticity, different regions of your brain are constantly fighting for physical territory. In 2013, researchers at Harvard tested exactly how aggressive this competition is. They placed subjects in a scanner and covered their eyes with a tight blindfold, completely cutting off all visual input. Look at this neural map. When the eyes go dark, the brain immediately starts rewiring itself. Within a remarkably fast 60 to 90 minutes, silent neurons from the auditory and tactile regions aggressively reach over and start firing inside the visual cortex. Neuroplasticity means your brain is highly adaptable, but it comes with a severe vulnerability. The moment a piece of neural real estate stops receiving input, it is in immediate danger of being permanently hijacked by the other senses. This microscopic vulnerability creates a massive biological problem, because we live on a planet that rotates. Every single night, early organisms were plunged into extended, inescapable darkness. When the sun goes down, you can still hear the wind, you can still smell predators, and still feel the ground. Your other senses continue processing data perfectly. Your visual system goes completely dormant. For millions of years of evolutionary history, night meant total sensory deprivation for the eyes. Artificial light is a tiny recent blip on our timeline. So, if an animal curls up in a dark cave to sleep for 8 hours, how does its dormant visual system survive until morning without being entirely overwritten by touch and hearing? The rotation of the planet forced biology into a corner. The brain either had to accept losing its ability to see, or it had to evolve an automated defense mechanism. Neuroscientist Dr. David Eagleman calls this the defensive activation theory. In this framework, your dreams are an automated, heavily fortified security protocol. This 3D schematic illustrates the hardware. An ancient circuit originates deep in the midbrain, travels to the lateral geniculate nucleus, and wires directly into the primary visual cortex. That's its only path. Every 90 minutes, this circuit slams electrical activity straight into the visual center. Because the brain naturally acts as a storyteller, it takes this random barrage of visual static and forcefully imposes a plot, meaning, and emotional weight onto it. You perceive it as riding a camel across a meadow, but the bizarre story is a byproduct. The true function of the dream is a biological heartbeat, a loud warning shot declaring to the other senses that the visual territory is highly active and fully occupied. You can test the mechanics of this theory by looking at individuals born completely blind. In a blind brain, the occipital lobe at the back of the head is entirely repurposed. Without input from the eyes, touch and sound successfully take over that exact neural real estate. But the ancient midbrain circuitry doesn't know that. The 90-minute timer still goes off, firing a massive blast into that exact same region. Now it hits different sensory hardware. As a result, blind individuals experience rich, intense dreams constructed entirely out of spatial awareness, touch, and sound. They might dream of feeling their way around a rearranged living room, or hearing an animal chasing them. This perfectly aligns with the data. The dreaming circuit doesn't inherently create pictures. It simply blasts whatever sensory network happens to own that territory in the dark. If this defense mechanism is driven by neuroplasticity, the math should hold up across the entire animal kingdom. Well, look at animals born essentially mature. A giraffe drops out of the womb and starts running within an hour. Because their survival requires immediate physical capability, their brains are hardwired at birth, making them highly rigid. Animals like zebras share this trait. Because their brain map is locked in and safe from other senses migrating over, they experience drastically less REM sleep. The biological rule is clear. The more hardwired a brain is at birth, the less it needs to deploy an automated defense system at night. Homo sapiens fall on the extreme opposite end of this biological spectrum. Humans are born slow, helpless, and completely unformed. We require an incredibly long infancy to learn how to walk and survive. This requires a hyperplastic brain, putting human visual processing at maximum risk for sensory hijacking. This is why a human infant spends a staggering 50% of its time asleep in REM. That peaceful rest is actually an intense, active state of neurological defense, keeping the vulnerable visual cortex intact while the baby develops. As we age, our brains slowly harden, and exactly as the theory predicts, the frequency and duration of our REM sleep drops accordingly. Dreams are a vital biological heartbeat. Every night while you lie in total darkness, your brain aggressively fights to hold its territory, so that when you open your eyes in the morning, you can still see the world.